If you're watching this, then you're watching my third installment of my rampaging deconstruction of Inspiring Philosophy's videos. While this ongoing YouTube project has been rather fun over the last few weeks, I want to make a more serious statement regarding intellectual honesty and pretending to know things that you clearly do not. Now, don't get me wrong, I'm not asserting that IP, Rods, and others are being deliberately dishonest, but I find it rather strange that they so casually produce material that concerns very, very arcane topics and come to radical conclusions that would put them vastly at odds with the scientific community. Another concern I have is whether or not their subscribers base has any understanding of such topics, or even enough to understand what they are accepting as true. I'm a university student, studying for a degree in electrical and computer engineering with the hope of going into the field of optics and quantum electronics. However, I am by no means a physicist, nor do I pretend to be. And that's the thing. I only speak about things to the extent to which I know them, and after that, I can only refer you to someone else. I know a lot, my friends say, but I don't know everything. When I try to make these videos, I try to make them as accurate as possible and as articulate as possible in order to ensure that I'm actually informing the viewer rather than showering him or her with information concerning something about which the viewer knows little to nothing. If you've been watching IP's videos, there are two words that constantly show up as he tries to argue for his God.
Quantum mechanics, the quantum mechanics, 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 quantum mechanics in 1925.
As I mentioned before, I'm not a physicist. To date, I've taken 2 classes in quantum mechanics, and I am currently taking a graduate level class in semiconductor nanoscale device physics. But I know enough to know that IP hasn't got the faintest clue as to what he's talking about, and this worries me. If there's anything I learned from those previous classes in quantum mechanics, it's that quantum physics is very difficult and very counterintuitive to the way we experience the world. In a way, it frustrates me because it's not necessarily something that a simple layperson can just pick up. It requires fairly large amounts of time and study to understand. What's worse is that the layperson can easily be led astray if trying to achieve an elementary understanding of this topic on the internet, because the internet is a haven for
science and pseudoscience and non-science, junk science, voodoo science, pathological science, bad science, non-science, and plain old nonsense.
While the myriad of refutations of the classical arguments for God's existence are littered throughout the YouTube universe, theistic idealism is something new that has not been addressed. Theistic idealism is just another flavor of the nonsense that I call new woo. IP's video in particularly misrepresent the findings of the field of quantum mechanics, a field, mind you, whose interpretations are not even agreed upon by scientists. One thing I've noticed about the responses to IP's quantum and philosophy videos is that they're noticeably long, and for good reason. This isn't like creationism when you can just refute Kent Hovind's points by thinking for 10 seconds, or even by reading the Answers in Genesis website. This is a field that not only has hotly debated topics still to be sorted out, it is one in which even legitimate physicists have fringe and wacky views. This fact should be a reminder to us skeptics that even smart people can succumb to irrational and unsupported ideas. As of now, I formulated the video in my head, and what I'm looking at is over 30 minutes of refutation as of now. The script for this video will be progressively written so that as I come across a particular point of disagreement, I can write my deconstruction of that point as meaningfully and as articulately as I can. So far, I've received good feedback concerning the explication of my objections to his videos, and I very much appreciate this. So before we delve into the video, I want to make 2 apologies. The first is to those who will have trouble understanding what I'm trying to say. Quantum mechanics can be that way. I'll link everything I can in the description box. If you have any questions, you can put them in the comment sections or private message me. The second is to those whose eyes will glaze over in the first 7 minutes. I apologize. I will try to be as clear as I can, although that will very likely extend the duration of the video. All I'm thinking now as I tackle this massive gish gallop of quantum information pseudoscience is that I hope I haven't bitten off more than I can chew. The video to which I'm responding is entitled Quantum Physics Debunks Materialism. So let's begin. So right away, IP quotes Eugene Wigner, a mathematical physicist known for his contributions to both atomic physics and the development of the principles of symmetry that are applied in elementary particle physics. While Wigner is not a person whom physicists would refer to as a complete quack, as he won the Nobel Prize, toward the end of his life, he became very philosophical and developed an interest in the Vedantic philosophy, an ancient Hindu philosophy that holds that the universe is an all-encompassing consciousness, similar to Brahmanism. This philosophy very likely influenced his interpretation of quantum mechanics, as he saw consciousness as a fundamental necessity to understanding quantum physics. However, this view is neither mainstream nor orthodox.
Materialism was the view of many scientists at the turn of the 20th century. This simplistic view that all that existed was matter and energy, and the rearrangements of it, is the extreme view of realism. Realism is a general belief accepted by many today, that a physical reality exists independent of observation. And roughly 100 years ago, most held to one of these two views, rejecting the opposing view, idealism, the view that reality is a mental construct, and doesn't exist independent of observation. For many back then, their understanding of physics seemed to favor this side of the spectrum, firmly believing it buried idealism. However, this realistic worldview was shaken with the advent of quantum mechanics. The realization of how the quantum world behaved began to eat away at the materialist and realist beliefs. Matter was thought to be tiny particles that existed independent of our observation. However, the equations of quantum mechanics and the results of the double-slit experiment changed that. To understand what this experiment showed, a simple explanation is given. Subatomic particles were thought to exist like tiny bits of matter, not like continuous waves of energy. However, sending electrons through a double slit showed they acted like waves of energy instead of tiny bits of matter. Even sending one electron through at a time, the same results happened. However, when one set up a measuring device at one slit, the results changed, and the electrons acted as one would expect, as tiny bits and not spread out waves.
When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched.
While IP did describe the double-slit experiment fairly for the most part, the part on which many people get lost is what is meant by an observer. You see, as a matter of physics, it cannot be a human observer, as our eyes are not sensitive enough to see the low-intensity light that is frequently dealt with in these types of experiments. Moreover, the wavelengths used are far from visible. You have to understand that IP relies on these fringe science quacks to produce these videos. His Dr. Quantum videos are produced by physicist Fred Alan Wolf. Wolf is a fringe physicist whose quantum consciousness ideas have been featured in both The Secret and What the Bleep Do We Know, just to give you a matter of perspective. Unlike IP, I will actually tell you what is meant by an observer in regards to this experiment. You see, the classical picture of light is as a continuous wave that moves in the air, or in a vacuum. On the classical picture, when light passes through a slit, it forms cylindrical waves, and then it passes through two narrow slits and disperses into an interference pattern on the screen. Here are two clips explaining the concept with water waves.
This spreading out of a wave as it passes through an aperture is known as diffraction, and it's a property of all types of waves. So what do you think controls how much the wave spreads out? Well, one possibility is the width of the aperture. And what do you think would happen if I made the aperture smaller? Well, you might be surprised to learn that a narrower aperture leads to more spreading out of the wave, more diffraction. If instead I make the aperture wider, then after it's settled down, you can see that the wave becomes less spread out. The diffraction is less pronounced. And if I were to make the aperture very wide indeed, then there'd be hardly any diffraction. To demonstrate diffraction with light waves, I need to use much smaller apertures. I also need to use a different light source, one with a very narrow beam and a very narrow range of wavelengths. And in order to achieve that, I'll be using this laser beam. And of course I'll be taking care not to look directly into the beam. Now this slide contains the apertures I'll be using, and in fact the first one is just 60 micrometers wide, or 60 microns for short. That's about 1/16 of a millimeter. So if I place this slide in front of the laser beam, you'll see the diffraction pattern on the screen over there. The aperture is aligned vertically, and that sharp spot of light has clearly been spread out or diffracted in a horizontal direction by the small aperture. You can see that the diffraction pattern consists of a series of dark and bright regions spaced regularly either side of the centre. The image appears bright in regions of so-called constructive interference, where light waves from different parts of the aperture combine to reinforce each other, and dark in regions of destructive interference, where light waves combine in such a way that they cancel each other out. The double-headed arrow indicates the width of the central bright region. This spreading of the laser beam shows that light does indeed propagate like a wave. Now, if you remember with the water waves, you saw that changing the aperture changed the amount of diffraction. So again here, if I use a smaller aperture, you should see that the diffraction pattern spreads out more. This next aperture is just 30 microns wide. Again, the double-headed arrow indicates the separation of the first dark regions on each side of the centre. And if I swap again to an aperture that's 120 microns wide, you can see that the diffraction pattern becomes less spread out.
Well, if light were behaving as particles, you would expect them to go through each slit and just produce a bright spot underneath, so we would see two bright spots on the bottom of the box. But if light's behaving as waves, then the wave from one slit can interact with the waves from the other slit. I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there. And this is exactly what was happening with the light.
So you get the idea. However, it does get interesting when one discusses the act of observation, and here's usually where people are led astray. Now understand that the classical picture of light still manifests itself even when dealing with just one single photon at a time, which was puzzling to physicists, so they decided to make an observation. In these types of experiments, observation is done by a detector, usually in the form of a photomultiplier tube, not a human being. A photomultiplier is a class of vacuum tube that is made to detect very low intensity ranges of the electromagnetic spectrum. The photodetector must interact with the photon in order to know the slit through which it went. The first stage of the interaction is when the photon collides with the photocathode material. Through the photoelectric effect, this collision produces electrons that are then multiplied by a process known as secondary electron emission. During the process of secondary emission, electrons are sent to an electrode called a dynode, where they collide to create new electrons. This process iterates itself and builds up until the last dynode is reached, at which a very powerful pulse of electric current is generated, signaling the arrival of the first photon. Where in this explanation did I need to invoke the idea that the consciousness of a living organism changes the photon? Nowhere, because I didn't have to.
The conclusion was drawn that the very act of observing caused a wave function to collapse and create the existence of matter, either in the state of particles or as a wave. According to the Schrödinger equation, independent of observation, particles exist in a state of a wave function, which is a series of potentialities rather than actual objects. The very act of observing caused this wave of potentialities to collapse to a state of matter.
I don't like IP's phrasing of what the wave function actually is. The wave function does not have a physical reality. It's just a mathematical model that describes the expectation values of particular observables of a quantum particle or system. The act of observing does not change the particle. The act of observing allows for greater precision as to the actual state of the particle, but it is not as if the particle didn't have any properties prior to measurement. It just means that you must perturb the particle in some fashion, as I have just described, in order to know its actual properties rather than what is described by the wave function.
State of matter. The results inferred was that matter didn't exist independent of observation or measurement, flipping materialism up on its head.
You, sir, are an idiot.
To better explain this, in the quantum enigma, Rosenblum and Kuttner explain with a simple scenario, representing what is actually happening. If you were to take an electron and isolate it in a superposition of two boxes, and open one box, the electron will collapse in either one or the other box. So if you don't see it in one, it will definitely exist in the other. However, if you were to take another pair of boxes and open both simultaneously, the electron would come out of both as a spread-out wave. It would display the wave of potentialities as an actual spread-out wave. The key to understanding what is happening is that matter doesn't exist as a wave of energy prior to observation, but as a wave of potentialities prior to observation. The waviness in a region is the probability of finding the object in a particular place. We must be careful. The waviness is not the probability of the object being in a particular place. There is a crucial difference here. The object was not there before you found it there. These were the conclusions drawn from the Schrödinger equation and the experimental results at the time.
It wasn't there before you found it there because you perturbed the system to make a measurement. And the Schrödinger equation has no philosophical implication.
It was only reconfirmed in the 1960s by Klaus Janssen. At that time, though, not everyone liked the conclusion that was playing out. Some, like Einstein and Schrödinger, were deeply troubled by the results of quantum mechanics. So in 1935, Einstein and two of his colleagues proposed a thought experiment to debunk quantum mechanics. They proposed that if you placed two particles in a joint superposition and then separated them by a great distance, an observation of one would instantly affect the other, which Einstein called a spooky action at a distance. The point was the observation of one couldn't affect the other instantly, because information couldn't travel faster than the speed of light. If it did, then relativity would be violated, which didn't seem possible at the time. So instead, there must be some physical, undiscovered, local, hidden variable that was actually affecting them instead of our observation, that matter acted independent of observation and only appeared to be observer-dependent from our perspective. However, in the 1960s, John Bell began to explore this thought experiment and propose an inequality. If this inequality was shown to be false, then the local hidden variable theories would be debunked, and matter would be dependent on observation. This was put to experimental test in 1982 by the physicist Alan Aspect, and the results confirmed Bell's prediction. Bell's inequality was violated. Einstein's spooky action at a distance was real. This confirmed what quantum mechanics was telling us. Prior to measurement, objects have no defined properties or location. The act of a conscious observer creates the existence of the physical objects and the properties they entail.
John, I just want to correct an error that, I don't think you meant it, Ian, so I want to just make it clear. The laws of physics are deterministic. The Schrödinger equation, which is the basis of quantum mechanics, is a second-order differential equation, and therefore the laws are deterministic. Our observations aren't deterministic, but the underlying laws are deterministic. Nothing's changed in 400 years. And so it's really important to recognize there's no way...
The universe isn't deterministic.
Wait a minute.
It's governed by quantum mechanics.
Just one thing, because we got into 4 syllables and I'm not that smart. Just give us a working definition of the word deterministic. You mean
you start with an initial condition for the equations of quantum mechanics, and the evolution of the system is determined unambiguously.
It has
with
to
no
happen.
uncertainty. Your measurement of the system has uncertainty, but the evolution of the underlying system is completely determined.
Krauss is right. You see, in 1913, Niels Bohr introduced his idea of the Bohr model of the atom, in which he referred to electrons as circling the nucleus of the atom in what is called a stationary state. And while he turned out to be wrong in this formulation of the mechanics and dynamics of what goes on in the atom, he got the concept of a stationary state right. In quantum mechanics, stationary states are states for which the probabilities of outcomes are the same regardless of when the measurement is made. The particle had properties independent of a mind, if IP wants to use that word, or rather before measurement. It's just that the measurement introduced external factors that affected the time evolution of the system. If what IP was saying were true, then it would be mathematically impossible to solve for the eigenstates of the observables in a quantum mechanical system.
Instantly.
Who deserves to trust their intuition more than Einstein? And Einstein's intuition told him, like everybody's intuition tells them, that things are really there when you're not looking at them. Well, he was wrong, right? That intuition is incorrect.
And now for a proper explanation by Dr. Victor Stenger on For Good Reason.
So in physics, there's this notion of wave-particle duality, and that notion in quantum spirituality, call it, becomes somehow proof that we make our own reality, that the way we look at things determines what we're looking at, right?
Yes, that was a gross misunderstanding of quantum mechanics that goes back to some of the things that Niels Bohr had talked about in the 30s. And unfortunately, I think he and some of the other physicists who were philosophizing about it were kind of careless with their language, which is a bad thing to be when you're philosophizing. The last thing you want to do is... that's why philosophers, in a way, I kind of admire them because they are such sticklers on making sure they define every word that they use. Well, physicists are not used to doing that, and so it got kind of out of hand.
Deepak Chopra and also Fritjof Capra, the Tao of Physics. On one level, all this stuff basically says something kind of sensible, that physics shows us that literally everything is interconnected. I mentioned the hot dog vendor spirituality, make me one with everything. But isn't it actually true that everything is connected? So they do have a point there, right?
Yes, but here's the difference. Let me give some examples of how this works. Say when your car, the oil pump in your car breaks down. So what do? You replace the oil pump. You don't also change the tires and get new brakes and so on. And that's what's called a reductionist view of things, where everything is broken down into parts, and you can handle the parts individually. In medical science, it's the same way. They like to pay a lot of lip service to treating the whole patient and so on, but they don't. I mean, the doctor goes in there, and if you have a kidney problem, he fixes your kidneys, and so on. And then what happened, interestingly enough, with Capra had been involved in experiments that were, in a theories actually, theoretical work in Berkeley, that seemed to confirm the ideas that he was writing about in the book. But the very year that he published the book, 1975, was the year that those ideas were rebutted.
What were the ideas exactly? I mean, so his claim was that on the quantum
level... he was working
level,
at Berkeley at the physics department with a very prominent professor named Jeffrey Chu, who had this idea that you couldn't break matter down into elementary particles, but that you had to treat all the particles the same way. He called it nuclear democracy. And I remember that very well because that was at about the time I just started doing my research, and I was working in that area myself, so I was very familiar with it. And then what happened at the very year that Chopra wrote this book, which he made a big point of this research. It was also called S-matrix theory, I think, in the book. You'll see it referred to that way. The new standard model of particles came along, which showed once again that everything breaks down very nicely into individual parts. That was when the quarks were discovered, and was realized that that nuclei and neutrons and protons were not elementary, but they were made up of more fundamental objects. And now we've had, for 30 years now, we've had this totally reductionist theory of matter called the Standard Model that has been consistent with every observation that anybody has made in any field of science. There's nothing that anybody has done that shows any inconsistency with a totally reductionist view of reality.
But Vic, these quantum spiritualists, these quantum theologians, use that evidence, even of the last 30 years, to say, aha, it proves my point, that at the most basic levels of physics, everything is connected, and, you know, so you hear things about, like, quantum indeterminacy or something somehow allowing for communication between locations that are light years apart or something, because the electrons, you know, electron could move here but also cause an effect light years away or something. Do you follow what I'm saying?
Let me go back to something you mentioned earlier, because it is the key behind all this, and that is what was called the wave-particle duality.
Yeah.
And that was that, this is again early in the 20th century, it was discovered that light was made up of particles called photons. We call them photons. And it was also discovered that
it was waves.
So light, was previously thought to be a wave phenomenon, also turned out to be a particle phenomenon. And then it turned out that particles, things that we were accustomed to thinking of particles, electrons, for example, behaved like waves. And so it seemed like it behaved one way or the other depending on what you decide to measure. If you decided to measure a particle property like position, then it was interpreted as a particle. And if you decided to measure a wave-type property, such as the wavelength or frequency, then you said the thing was a wave. And that was where that duality came in, and it seemed like consciousness. We were consciously deciding whether something was a particle, whether it was a wave. In fact, a famous physicist, John Wheeler, pointed out that you could do an experiment on a photon from some distant galaxy 13 billion light years away that left there 13 billion years ago, and you can decide in the laboratory today whether you're going to measure one thing or another. So this idea that your consciousness is affecting reality not only refers to now currently in the laboratory, but 13 billion years in the past, 13 billion light years away, all over the universe. So here it is, your consciousness is supposed to affect everything throughout the universe. And that's exactly what these people are teaching. If you read what Chopra and there's other people that write with him are saying, that's what they're saying, that we're tuned into this cosmic consciousness that is all over the universe, and we're part of that. And the whole point is that this wave-particle duality thing was a total misunderstanding.
But it doesn't end there, because many propose the existence of non-local hidden variables in Leggett's inequality. However, in 2007, they were also falsified, this time by Anton Zeilinger and his team. The results sent shockwaves, and physics world went so far as to say this means quantum physics says goodbye to reality.
So recent experiments led by the group at the University of Vienna, Austria, provide the most compelling evidence yet that there is no objective reality beyond what we observe. So it's really the observation that creates the reality. And what they found is that Leggett's inequality is violated as well as Bell's. Even if you allow for instantaneous influences, quantum measurements do not fit with the idea of an objective reality. So as they say in the magazine, rather than passively observing it, we in fact create reality.
A reality independent of observation doesn't exist.
So, two things here. The first is that physicist Bernard Heisch is right. Quantum mechanics does not fit with the idea of an objective reality in that The observables or properties of quantum mechanical systems are not well defined past some uncertainty. This obviously contrasts with the macroscopic world. Heisch was not making a claim about the whole of reality itself. He was just saying that the observation is what creates the definite reality of understanding the properties of quantum mechanical systems. These properties are termed observables. This is not because they have anything to do with a conscious mind observing anything. It is because these properties are fundamentally ill-defined as shown by Heisenberg's uncertainty principle. The second thing I want people to consider is the person IP is citing. Bernhard Heisch, whilst a well-respected astrophysicist, was also an editor for the Journal of Scientific Exploration magazine, a magazine which addresses, quote, topics outside the established disciplines of mainstream science, such as paranormal effects, UFOs, and cryptozoology. Heisch also has published papers in the Science and Spirit magazine, a discontinued magazine that was once funded by the Templeton Foundation that focuses on the spiritual implications of scientific findings. Here, IP cites another scientist who is entangled with Wu.
But it doesn't stop here. Prior to this in 1999, the delayed choice quantum eraser experiment was performed. If I'm going to simplify and explain this complex experiment, we need to do so with a hypothetical scenario of modifying the original double-slit experiment. Instead of placing the detector at the slit, it is placed past where the particles land. But just before the particles hit the film, it is pulled away and the camera captures the results after they went through the double slit. If they observe a wave, then particles went through the double slit as a wave, and just adding a measuring device doesn't cause them to collapse to particles. But if they collapse to a state of particles at the moment of detection, then even though they went through the slit unobserved and should produce a wave pattern, the very act of observing instantly transforms them into particles. But not only that, a back history is loaded up so that particles went through the double slit instead of a wave. Well, to the dismay of materialists, the results would display particles. Observation creates the existence of particles and loads up a back history so they went through the double slit as particles. Thus it follows particles do not exist unless there is an observer.
Wrong, sir. Wrong!
Knowing which slit is not the same as knowing the path, which cannot be known because of the properties of the particles mid-flight are fundamentally inaccessible to us knowledge-wise. And it does not collapse the wave function, instead it prepares the system in a different wave function depending on the approach to measurement. During the delayed choice quantum eraser experiment, a process known as spontaneous parametric down conversion creates the two entangled photons of lower energy and frequency. This is usually done by a borate barium crystal or some other sort of nonlinear optical device. In this way, the experimenter is, in a sense, preparing the wave function with an initial condition. It can be said that the wedge path information of any quantum mechanical experiment reduces the state vector simply because the preparation of the system at any point in time of observation is such that an amount of information which would tell you one of the many eigenstates or paths of the superposition is known to be the definite state or path. Now you're probably wondering, why does it depend on the knowledge of? Well, it doesn't. It depends in principle on the knowledge of. As long as you could, in principle, make the measurement that gives you the knowledge of, that's where the dependence of the behavior of the particles lies. And it depends, in principle, on this knowledge for the simple reason that the system itself is information.
But the problems don't end there for realists. Many try to explain this away and hold to naive realism, which holds to the belief that a reality exists independent of observation, just that our perceptions are just a representation of something that is actually there, but not a perfect representation. However, this view was also falsified in 2011, this time by confirming the Cauchy-Spector theorem. The outcome of observed reality depends on the measurements at the time and cannot be predicted prior to that, which would be essential for naive realism.
The Cauchy-Spector theorem talks about properties of one system only. So we know that we cannot assume, to put it precisely, We know that it is wrong to assume that the features of a system which we observe in the measurement exist prior to the measurement. Not always, I mean in certain cases. So in a sense, what we perceive as reality now depends on our earlier decision what to measure.
While I do in fact agree, IP grossly misrepresents what the Cauchy-Spector theorem says. You have to understand that when scientists discuss quantum mechanical systems, they're discussing something that is very minute. This minuteness means that the observables of quantum mechanical systems are not measurement independent. The result of our measurements inexorably affects the value of the observable that we measure. This is known as the principle of contextuality, which is again derived from Heisenberg's uncertainty principle. Bohr pointed out the errors in the EPR hidden variable treatise, and the Cauchy-Spector theorem shows that in at least three-dimensional space, the observables of quantum mechanical systems are context-dependent, but this is insignificant on a macroscopic scale. So I don't know what IP is pointing at.
Which is a very, very deep message about the nature of reality and about our role in the universe. We are not just passive observers.
Then there was also the experiment in 2012, the non-local delayed choice quantum eraser experiment, and the results were quite astonishing. It concluded, no naive realistic picture is compatible with our results, because whether a quantum could be seen as showing particle or wave-like behavior would depend on a causally disconnected choice. It is therefore suggested to abandon such pictures altogether. Thus the conclusion is inescapable. This is why Eugene Wigner could safely say years ago that materialism is not compatible with quantum mechanics. And now with these recent experiments, we can also roll out versions of local realism and naive realism. Not only is materialism incompatible with quantum mechanics, but so is realism. As Zeilinger said, we have to give up the idea of realism to a far greater extent than most physicists believe today. Now if one wishes to just dismiss all of this, I can simply refer you to the Quantum Randy Challenge, where you can win a Nobel Prize and prove naive realism or local realism is true, and not observation dependent. Until then, to just dismiss all this science pointing in the opposite direction is nothing more than a faith-based opinion.
Something that I didn't address before is that IP is actually in a state of massive confusion regarding the implications of specific inequalities and their role in physics. You see, there is the Leggett inequality, and there is the Leggett-Garg inequality. The Leggett inequality concerns local realism in quantum mechanical systems. However, the prohibition of local realism becomes less relevant as one scales up. Often forgotten in these discussions of quantum pseudoscience is the principle of complementarity. Only on small scales is there the probabilistic component of quantum mechanics. As one scales up, the probability averages out, and you don't have to deal with these sorts of wave function outcomes when you're discussing physical systems. For example, a scanning tunneling microscope uses electron tunneling to build a 3D picture of a sample. As an individual, an electron has a certain probability of tunneling between the sample and the tip of the microscope. However, as the number of electrons increases, the tunneling probability becomes the fraction of the electrons that tunnel. Leggett-Garg inequalities are different. Leggett-Garg inequalities apply to macrostates. Now, the Leggett-Garg inequalities are violated at the Big Bang because the Big Bang is a microscopic quantum mechanical system. However, Leggett-Garg inequalities have not been demonstrated to be violated at the macro level, and many scientists, including the one who wrote my solid-state physics textbook and who is a professor at my school, have criticized experiments that would supposedly show that the Leggett-Garg inequality would be violated at the macro level.
Now many have tried to get around this by trying to separate the quantum world from the macro world, but that was also falsified in 2010 by violations of the Leggett-Garg inequality. And in 2011, Bruckner and Koffler showed that macro-realism does emerge from quantum physics, so you cannot separate the two. This should be obvious since double-slit experiments have been performed successfully with larger things like atoms or molecules, and experiments are being devised on how to do this with mid-sized proteins and viruses, and no one doubts the results will be different. Other elements of quantum weirdness have been seen in macro objects as well, such as quantum entanglement between two aluminum chips, big enough to be seen by the naked eye, and putting a small metal paddle in a quantum superposition. So the idea that we can escape by postulating the macro world is separate from the quantum world doesn't work either.
So, in the example which IP just gave, the micro-macro distinction isn't really relevant because we're talking about something completely different. If you have ever taken a course in microelectronics or device physics, you'll learn that when the spacing between identical particles becomes comparable to the de Broglie wavelength, quantum mechanical effects become important, and classical mechanics can break down. Although these experiments usually happen when those objects are supercooled to just an epsilon of a degree above absolute zero. Supercooling lowers the energy of a particular particle or object or molecule, which then increases the de Broglie wavelength, allowing for more spacing between particles. Those would be the types of situations about which IP speaks. If such experiments were done with objects like candy bracelets and toothbrushes, IP could have a point.
The macro world is built by the quantum world. Another escape route many materialists use is to hold to the many world interpretations of quantum mechanics, which basically argues there is no collapse of the wave function upon measurement, but that every possibility splits off into different worlds. So every quantum probability actually does play out. They just split off into different worlds, and in each one I'm observing each different outcome. But it is riddled with problems, unlike the idealist understanding, and it is an apparent violation of Occam's razor.
Well, I guess that's the definition of the word irony.
As entities are not to be multiplied beyond necessity, introducing a large number of worlds that we also cannot detect is an extreme violation of this, especially since this can be explained by accepting all these possibilities just exist in mathematical probability as a wave function, instead of as actual worlds that can never be verified or falsified. An idealist understanding can explain this just fine, with much less and other aspects of reality that we dealt with in our last video. The many worlds interpretation doesn't have enough explanatory power and has to postulate so much more in order to explain the little it can. As Bernard Hosch says, one tiny atom's quantum behavior replicates the entire universe and defines each alternative by all the possible consequences of that behavior. But at any moment within each human body, there are on the order of a billion times a billion times a billion atoms, each making quantum transitions. In the many worlds interpretation of quantum mechanics, every human being therefore creates a billion times a billion times a billion alternative universes every second. So this is absurd to postulate and unnecessary to do so. The last and important objection that may bring up is that this leads to solipsism, which is false. Solipsism, for our purposes in this case, would be the extreme skeptical version of idealism, which says only your mind exists and everything else is an illusion. But that doesn't have to be the case, as general forms of ontological idealism just say the appearance of the physical world is created by the activity of the mental world, not that only your mind exists. In a short article ranting about why materialists cling to false notions of an independent material reality, Richard Conn Henry and Stephen Palmquist say, why do people cling with such ferocity to the belief in a mind-independent reality? It is surely because if there is no such thing as reality, then ultimately, as far as we can know, mind alone exists. And if mind is not the product of real matter, but rather is the creator of the illusion of material reality, which has in fact, despite the materialists, been known to be the case since the discovery of quantum mechanics in 1925, then the theistic view of our existence becomes the only rational alternative to solipsism. And now let Mikio Kaku explain why this is the case.
Erwin Schrödinger, one of the founders of quantum mechanics, designed a thought experiment to drive home the strange rules of his theory. Let's say we put a cat and a vial of poison in a box. We add an atom of radioactive uranium and a Geiger counter. If the uranium decays, it sets off the Geiger counter, which then releases the poison and silently kills the cat. Before we open the box and look, we can't actually know whether the uranium has decayed or not, since radioactive decay is a probabilistic quantum event.
Here's the question. Is the cat dead or alive? Well, according to quantum mechanics, the cat is neither dead nor alive, but the sum of the two states. Well, at that point, you say, well, that's nonsense. That's preposterous. How can you be both dead and alive simultaneously?
Schrödinger's cat was supposed to show that nothing in this universe is certain until someone makes a measurement. But another pioneer of quantum mechanics, Eugene Wigner, believed it could teach us something else about the working of the universe. That consciousness controls everything.
Wigner said, let's take it one step farther. If I, a human being, looks at the cat, I am conscious. Therefore, consciousness determines existence. At that point, Einstein went ballistic and said, what? You're saying that the fact that you are a conscious being determines the fact that the cat is alive? Answer is yes. And Wigner made one more step. And that is, how do I know I'm alive? You see, the cat and me, we're part of the same universe. If I don't know the cat is alive or dead, I could also be dead at the same time and not even know it. So who determines that I'm alive? Well, Wigner's friend looks at me, I look at the cat, and we exist. But then who looks at Wigner's friend? And there's an infinite chain of people looking at people, looking at people, until finally you hit cosmic consciousness. Some consciousness that's ethereal, that envelops the universe, which looks at us and says, aha, the cat is alive.
I would even go as far to say that this position is more logical than the solipsist position, because in this case one can point out that our mind doesn't create reality, it only participates in it. In other words, we are not the architect, or have the ability to change the structure of the world through mental processes. Remember the scenario set up in the quantum enigma about opening the box. If we decide to look in one box and find where the atom is, we do not actually decide where it will end up. We just use our free will to participate in deciding what the outcome will be, whether a wave or a particle result. But we don't get to choose the specifics. So the evidence suggests we are just lesser minds dependent on a much larger one that is actually in control of the structure of the experience.
Anyone dumb enough to take Schrödinger's thought experiment literally, and who doesn't understand that it's simply a metaphor, doesn't deserve to be taken seriously, and you shouldn't be listening to his videos, especially when he's trying to further an agenda that misrepresents science in order to prove his imaginary friend. We're done.
And we are allowed to operate and be able to participate in the outcome of the idealist experience. Now, one objection to the theistic perspective is raised in the quantum enigma. If God is observing the physical world and us in it, then how come we can do experiments showing something unobserved is in a superposition? In other words, if God is looking down at everything, the strange rules of quantum mechanics should never have been verified, since they are always being observed by God. Well, this is a misunderstanding. God is not separate from us, someplace in space observing us, as space and matter are illusions of our conscious observation, as the falsification of realism shows. The existence of the physical world is created by our observation of it, and it doesn't exist other than that. So what is there for God to observe other than what we see? Consciousness is what is fundamental, and our consciousness would be dependent on a larger one. God is in a sense observing us having an experience of the physical world, and apart from our experience, there is nothing that needs to be observed, as it exists in the state of a wave function. So he is not separate from us, as our consciousness is dependent on his, and he doesn't need to see an independent experience of the physical world. So thus we can conclude no other. Given the scientific evidence that has led us this far, what other inference does this lead to? Of course, one can always refuse to go with us to the logical conclusion, but that does not refute the conclusion or change it. Science has not buried God, it has revealed him, and with it buried materialism. It remains now only in the fantasy of materialists.
Who's a moron? You're a moron! Yes, you are! Yes, you are!
day, sir!
Hold on. Here's a thought. The ideas and conclusions which IP conveys in his videos sound very similar to ideas I've heard from someone else. You'll be the judge of the accuracy of this comparison.
Materialism was the view of many scientists at the turn of the 20th century. This simplistic view that all that existed was matter and energy, and the rearrangements of it, is the extreme view of realism. Realism is a general belief accepted by many today, that a physical reality exists independent of observation, and roughly 100 years ago, most held to one of these two views, rejecting the opposing view, idealism, the view that reality is a mental construct, and doesn't exist independent of observation. For many back then, their understanding of physics seemed to favor this side of the spectrum, firmly believing it buried idealism. However, this realistic worldview was shaken with the advent of quantum mechanics.
I think I'm going to have to say that science is now in a process of overthrowing the climactic overthrow of the superstition of materialism. That everything that we call matter comes from something that is not material. That the essential nature of the physical world is that it's not physical. That the essential stuff of the universe is non-stuff.
According to the Schrödinger equation, independent of observation, particles exist in a state of a wave function, which is a series of potentialities rather than actual objects. The very act of observing causes this wave of potentialities to collapse to a state of matter.
And science also tells us, and if there are any scientists who want to disagree with them, please come up during the question and answer session. Science tells us that nature is a discontinuity, that it's an on-off phenomenon, that there are gaps between every two ons, where you find a field of possibilities, a field of pure potentiality. Science doesn't call it God, but what is God if not the immeasurable potential of all that was, all that is, and all that will be?
For objective reality to be true, and the world to exist independent of observation, something known as locality would have to follow, which means for objects to interact, they need to be in close proximity. But experiments in the early 80s showed this is not the case. Instant interaction can be seen between two particles that are separated from great distances. This is what we now know as entanglement, and it makes more sense if the world is virtual. In a virtual world, space doesn't limit correlations.
Science also tells us that this is a field of non-locality, where everything is correlated with everything else. My adversaries are going to point out, no, everything, God is explained by neurology. Well, I hope today, Michael, that you will convert from a skeptic to a neuroskeptic, because your science is really frozen in the dungeons of conservatism and in the dungeons of orthodoxy. Today, science tells us that the essential nature of reality is non-local correlation. Everything is connected to everything else.
If God is looking down at everything, the strange rules of quantum mechanics should never have been verified, since they are always being observed by God. Well, this is a misunderstanding. God is not separate from us, someplace in space observing us, as space and matter are illusions of our conscious observation, as the falsification of realism shows. The existence of the physical world is created by our observation of it, and it doesn't exist other than that.
That there's something called the observer effect, where intention orchestrates space-time events, which we then measure as movement and motion and energy and matter. We can have a personal relationship with this intelligence, because we have a consciousness that is part of the sea of consciousness.
Consciousness is what is fundamental, and our consciousness would be dependent on a larger one. God is in a sense observing us, having an experience of the physical world. And apart from our experience, there is nothing that needs to be observed, as it exists in the state of a wave function. So he is not separate from us, as our consciousness is dependent on his.
It is impossible for a physical system, no matter how complex it is, to process meaning, to process creativity, to process purpose, to process even, you can map that out, you can show the molecules there, but it is impossible for a physical system to feel those qualities.
The properties of the mind are not that which matter can have. This can be seen with the difference between mental properties and physical properties. Consider two things, feeling pain and an electrical signal to the brain. Are they the same thing? Of course not.
Our minds are not by themselves. They are part of a matrix of mind or information.
One can find a much simpler explanation that the universe is being simulated in a mind. This would solve many problems of being simulated on a computer, because a mind has elements of integrated information states and also processes information. Prior to measurement, objects have no defined properties or location. The act of a conscious observer creates the existence of the physical objects and the properties they entail, instantly.
The moon is really there whether you look at it or not. It doesn't apply to the macro world.
In the absence of a conscious entity, the moon remains a radically ambiguous and ceaselessly flowing quantum soup.
Deepak, that is...
That you have to have a conscious being.
The moon?
Yes.
Okay, listen to the sounds.
Will you really trust someone who spews as much bullshit as he does?
Rational arguments don't usually work on religious people. Otherwise, there would be no religious people.